parallel lines and transversals. So most of these problems were basically just stating like whatever the value of the angle is that's like we're trying to find, and then just stating the reason of why we know that that would be the value of it. So, and again, you will need to draw the pictures for these because that's the extent of the question. So we've got two parallel lines. Cut by a transversal this way. And the way, I don't remember if we talked about this, but the way that they show these lines are parallel is by putting these little like triangle things on them, showing that. So that way you know. This is 1 and this is 2. All right, so we have our picture here, and I'm trying to find the measure of angle 1 and the measure of angle 2. So the measure of angle 1 would be equal to what? 135, and what would the reason for that one be? Huh? Corresponding angles postulate. How about the measure of angle 2? What would it be equal to?
135 is the vertical angles. I'm not sure if it's postulate theorem.
The vertical angles theorem. There's also alternate interior angles theorem would have worked. Either of those would have been fine. So again, there were two possible answers basically for this one. That was just vertical angles was the first one that was said. But if all we had to go off of was the 135 and angle 2, it would have to be this one. But since we'd already found one, we could say vertical angles. No, because I said we're not going while I'm teaching. Yes.
So are we writing this in a column perfectly or just like this?
Just like this. 10. They give us, this one is 118, and then this is 1, and this is 2. All right, so what is the measure of angle 1?
118 degrees.
Why?
Alternate interior angles.
Yep, alternate interior angles theorem. What about angle 2?
62 degrees because supplementary.
Saying supplementary is not a theorem or postulate, so it's not going to work. How about, what are these two here together? What are these called? Consecutive interior angles. So this is where, obviously, having your theorem and postulate book or just flipping back and forth if you don't have your that book with you is going to help you, because you have to be able to say the correct thing for it. So consecutive interior angles theorem. And again, I'm okay with you abbreviating things as long as your abbreviations make sense and I can tell what it is. That is fine. And we did that because of 180 minus 118. case anybody wants to see the math. 12. Parallel lines are going up and down this time. This. These ones say to find the values of x and y, so basically just doing the same thing. We're just calling them x and y now. 109 degrees, this is x, and this is y. Alright, so somebody besides Jonathan, tell me what x is. Or to explain to me how to find x.
Consecutive interior angles theorem.
Yep, and so how would I solve, like, or how would I,
109 minus 180 minus 109 degrees equal to x.
yep. So then x is equal to,
91. Negative
71.
91.
So an angle is never going to be able to be negative, right? You can't have, I mean, well, it's a little bit misleading once you get to algebra 2. For the sake of what we're doing, you can't have a negative angle. So, but your reason was exactly right. Consecutive interior angles.
And then with the alternate exterior.
So for them to be exterior, they both would have to be exterior. They either both have to be interior, or they both have to be exterior to your parallel lines.
Oh, why would 109 is a vertical angle?
Yep, vertical angles theorem. Um, 14. What, or, well, it doesn't matter. Let's do x first. Let's do them in order. What would x be?
Maybe 65.
65, yep. And y? What is x and 65?
Corresponding.
Yep. Corresponding angles postulate. There was one place in my book that they put corresponding angles theorem, but I checked and it is a postulate, not a theorem, so just make sure you're just aware of that when you're checking. They only did it on one of them, so I'm assuming it was just a typo, but just in case that happens again, just be aware of that. And what about y?
What's 115 degrees, but I do not know.
So we would do 180 minus 65, which would give us 115 degrees. And what would the reason be for this one?
Linear pair.
Yep, linear pair postulate. All right, I want everybody to take a second and do this one on your own for just to make sure that we're getting it before we move on to the next thing. This is x, this is y. So I know you don't have all the names of all the things like memorized, obviously. I'm mainly worried about you finding the angles right now for this particular like exercise of you trying to do them by yourself. But if you know the reason, obviously put that down, or at least have in your mind what you think it is, so when we go over it, you'll know. All right, what did we get for X?
130.
And what would be the reason for that? Yep, corresponding angles postulate, it's just like the one we did above. And then what about Y? There's two different reasons I could argue for on this one.
It could be 130 because of the vertical angle theorem or the alternatives too.
Yep. So also 130. And like she said, if you hadn't already found X, then you could just say by the alternate exterior angles theorem. If you had found X, then you could obviously say by the vertical angles theorem. So either of those would be fine. The next set of problems, either, depending on the problem, either want us to solve for Y or for X. And we don't have to state the reasons for them, okay? Now, we may kind of talk about it as we go, but we don't have to, like, write the reasons like we were doing on these ones. So, 18, we have two lines going up and down. Like this. And this one they tell us is 70 degrees, and then this is 2y. So how would I set this up to solve? Do not tell me the answer. Tell me how to set it up. What's true of these two angles?
They're alternate interior angles.
They're alternate interior angles, and what does that mean?
2y equals 70.
Yep, they're congruent, so 2y is equal to 70. So what does that mean y is? 35. And again, they've already got the degree symbol, so you don't have to write it. If you do, I'm not going to mark it wrong, but that's all we're looking for on that one. 20.
Hi.
Hello.
Okay, so I wasn't here to take my test. So can I take it tomorrow?
Yeah, that's fine.
Because I was like, I got to the appointment and I was like, wait.
Yeah, no, you're good. Be careful.
Yeah, I can't hurt the other ones.
All right,
That's
this
my biggest fear.
120 and this is 6y. So what do we know to be true about these two angles?
Consecutive interior angles.
So what does that mean as far as setting them up?
120 plus 6y equals 180.
Yep, we add them together and they equal 180. So 120 plus 6y equals 180. Subtract 120, 6y equals 60. So y equals 10. This is an interesting one. 22. Lines are going this way this time. No, I didn't draw these on here, but it doesn't really matter. Got this going this way. Sorry, that was like way down at the bottom. There we go. Okay, so what does that tell us then?
That 2x plus 10 is equal to 90 degrees. Definition of 90 degrees.
Yep, so if this is a right angle, then that means all of these are right angles. So there's also a right angle here. So then alternate interior angles means these are congruent. So 2x plus 10 equals 90. So then 2x is equal to 80. So x is equal to 40. Now the other thing you could have said is alternate exterior angles. Tell me that this is congruent to this one, and these two have to add up to 180, so you could have also done it that way. But this was the faster, easier way, in my opinion, to do it. Let's do one more, 26. And then we'll do a proof one. So what has to be true about these?
They're corresponding angles.
So what does that mean?
126 equals 7 times 7 parentheses x minus 6.
Yep, so 126 equals 7 times x minus 7. So I would divide by 7 first, because then I don't have to distribute, and I'm ultimately going to have to do it anyways. Does anybody know what 126 divided by 7 is? It's not like super common, but 18. Yep, 18 equals x, yeah, minus 7. I don't know why I have a plus written on my paper. So then add it over, 25 is equal to x. So are we okay on ones like that? All right, let's look at one proof then, and then one other kind of like word problem type thing. Not really a word problem, but kind of is. All right, so 28. On these ones, they say complete the proof. This is proving theorems 3.6 and 3.7. So to prove the alternate exterior angles theorem, first show that angle 1 is congruent to angle 3, then the angle 3 is congruent to angle 2, and then the angle 1 is congruent to angle 2. So the given is that J is parallel to K, and we're trying to prove that angle 1 is congruent to angle 2, and they've given us a picture. I don't know why I just drew that so far down. So we've got 1 here, 3 here, and 2 here. All right, so I'm setting up a proof. They kind of give a plan for the proof. That's kind of what I read at first, but I just want us to walk through it as if they didn't give you anything, because on a quiz or a test, they're not going to give you anything. So we're going to talk through it that way instead. So set up your 2-column proof. All right, so what would be the very first thing that we should always start with? Given. So J is parallel to K, and that's the given. So I'm ultimately trying to prove that 1 is congruent to 2, because this is the alternate exterior angles theorem that I'm proving. So I can't just go straight and say, well, 1's congruent to 2 because of the alternate exterior angles theorem, because that's what I'm trying to prove, okay? So what I'm going to do is I'm going to say, well, I know that 1 is congruent to 3, right? So step 2 is angle 1 is congruent to angle 3. And what would the reason for that one be? What are these?
Corresponding angles.
Yep. Corresponding angles postulate. I also can see from my picture that 3 is congruent to 2. What is the reason for that? Yep, vertical angles theorem. Now, I have all of this information. I can now say angle 1 is congruent to angle 2. And what allows me to say that? Again, alternate exterior angles cannot be the reason because I'm trying to prove that theorem to be true.
The transitive property.
Yep, transitive property. So if you're trying to prove a specific theorem, you can't use that theorem to prove itself, obviously. So when you're doing number 29 as part of your homework, it's proving the perpendicular transversal theorem. You obviously can't use that to prove it. You have to use other information to prove that one.
Making life harder on ourselves.
Huh?
Making life harder on ourselves.
Yeah, it's like you can't define a word, or you can't define a word with itself. Like, I don't know, kind of the same thing. All right, so 30 gives us a picture, gives us a rainbow. I'm gonna use my highlighters to do it. You really don't have to actually draw it, but I think it makes it more fun, so.
That's actually tough. Messi might be an artist. Like Picasso.
I'm definitely not.
I was trying to help you.
I guess I should technically, add that and then do the purple, but whatever. Okay, there's my rainbow. Now, they give you a whole thing here in the word problem about when sunlight enters a drop of rain, different colors leave the drop at different angles, and that's what makes a rainbow. That's science class, not geometry. So, what happens here is they've given us this picture with, rain falling. And over here we have on the red, we have this spot that it's hitting the raindrop, and this is sunlight coming in, and then what color person do I want? Let's have a pink person. My person's over here. So now this comes off and hits his eyeballs, or her eyeballs, whatever. And then it angles down. We have a shadow here. I'm just copying the picture out of the book. I'm not making this up. Just make sure we're all aware of that. So these lines are parallel. They don't necessarily look like it, but I put the little things on there to show that they're supposed to be. And then this is angle 2, and this is angle 1. So then, as part of the problem, they tell us that the measure of angle 2 is equal to 42 degrees, and they want us to find the measure of angle 1. So, what is the measure of angle 1 and why? Yep. Alternate interior angles theorem. So again, you wouldn't have to copy the picture over. I was just trying to do it to help us see what's going on. Any questions about this stuff? All right. Problems. We should have time to knock most of them out. Are 9 through 29 odd. Only one of them is a proof. That is number 29. The other ones are, I lied. 27 is also a proof, but you're just filling in the pieces. The other ones are all just solving for X and Y. But remember, you do have to copy the picture over. Some of you did not follow instructions yesterday when you turned in your homework.